So I'm going to go through a tough bearing problem that I put on one of my exams. So this problem, so I'll just read it. So the bearing of point B from point C is 254 degrees. The bearing of point A from point C is 344 degrees. And the bearing of point A from point B is 32 degrees. If the distance from A to C is 780 meters, find the distance from A to B. So this one has a lot going on with it, actually. And so first things first, before you do anything else, you want to figure out what type of bearing problem is this. So the thing to notice within this problem is that we have this single angle. It doesn't have any other directions. So what this is telling us is that from each one of these points, we're going to go clockwise from due north, okay? So this has actually kind of a lot going on with this. So let's just get started. So let's start with this point B from point C. Okay, so let's say my C is here on north, okay? So from this bearing, I need to go 254 degrees. And so that will bring me to this side here that contains angle B, okay? And then, so then I go from point A from point C is 344 degrees. So I repeat the process. So now I've gone whoop 344 degrees. So this is going to erect this other side that has A here, okay? But now, so notice that for the next part of this, so I'm actually going to put just two kind of due north pieces in here. You'll see why I'm doing this as we go along. But notice that in the next part of this, so it says, so the bearing of point A from point B is 32 degrees. So now, here's my due north that B is sitting on. So from this kind of like pole, I need to go 32 degrees from this clockwise to get to the side of this triangle that's going to like share with A. So I'm going to go 32 degrees this way to get my other side. Okay. And then the other thing that this problem says, so from A to C, this is 780 meters. And then I need to find the distance from A to B. So this distance here. So, okay. So to find A to B, we're going to need to find now all the angles of this triangle. So I got rid of all the other noise for a moment in the problem, just so you can kind of see like, we do actually have a triangle, but I think one of the things that makes this problem so difficult is that there's a lot going on. There's actually quite a few angles here. So you want to keep in mind, like this is actually the goal, to fill in at least some of the angles. You don't necessarily need all of them, but we need enough so that I can use a trig function to figure out this side of AB. Now, the other problem is that at the moment, I also don't know what type of triangle this is. I am assuming it's probably a right triangle, but I can't assume. I have to prove it. So we have to use all of this information here, and I'm keeping these like little, due north things here so I can keep track of angles. It's going to help us as we go along. Okay, so first things first, I think probably one of the easiest angles to get is going to be this ACB, so this angle right here, because I have this giant almost circle, right? And then this tiny one, so I can pretty easily isolate what this piece is here by taking 344 minus 254, and boom, so that gives us a right triangle. So now we're in business. So now I can use my trig functions, so that's super great. Okay, so now the other thing that I'm going to do, and I'm doing this partially because I know where this problem is kind of going. So I need to figure out more angles. The next angle that I could most easily figure out, so if I know that this is 32 degrees, this is a parallel line, this is a parallel line. So I can tell right here that this is an alternate interior angle. So this also has to be 32 degrees, but to help me just label that, what I'm going to do is I'm going to just draw a solid pull through here, and I'm going to just put a dummy point X here. Also, because I know where this problem is going, I'm just going to throw a dummy point Y here. This will kind of help us as we're going along. Okay, so anyways, like I said, I can figure out, since this is 32 degrees, I know for sure that this angle here, this BAX, this is also going to be 32 degrees, but that doesn't totally help me, right? Because I need to know this entire angle, so we still have some work to do, but let's just hold on. Okay, so next, here's the other angle. So I need to figure out what is this YCA. So you'll see why in a second. But if I think about what is this YCA, well, I can pretty easily figure out this angle because I have all of this as 344. So from here to here, this is just going to be 360 minus 344, right? Because this is almost like a full circle going all the way around. So just this little part in here is going to be my YCA. So it's 360 minus 344, so that's 16 degrees. So the reason why this is helpful now is, once again, so if I know that this is 16 degrees, where do I know the other angle for free now? Well, the other angle that I'm going to know is in here, right? So now, let's see, so I'm going to label this. So here's 16, this is now 32. Okay, but now this XAC, so this angle in here must also be 16 because, again, it is an alternate interior angle. So this has to be 16, and so then I have this is 32, this is 16, 16 plus 32 is 48. So now I have that this whole side in here is 48. Okay, so this was a lot of work just to figure out one of these angles. Notice that I haven't figured out angle B. It doesn't really matter. As long as I have one of the angles of this triangle, I'm in business. So the reason why I bring that up is because now I can use my cosine function. So I know that the cosine of A, so remember that's going to be, so you think of your SOHCAHTOA, so cosine, that's going to be my adjacent. Here's my adjacent divided by my hypotenuse. So that's going to be AC divided by AB. So now we're in business, so I can clear some space. And now that I've done all of this work, it was like a non-trivial amount of work for sure. It was definitely tough. But now I can just plug everything in. So boom, there you go. And so if I do this now, so I can multiply both sides by AB and then divide the other side by cosine of 48. So here's the math here. So if I finish this, I get that this comes out to 1,165.69. And then depending on if you're doing significant digits or not, so I would have to round that to 2 significant digits. And so then that is going to be 1,200 meters. I don't think I called out like that you have to use significant digits. So if you're doing this for test corrections, you can really just leave it here. Technically, a lot of classes are going to make you do sig digits, so I do need to just mention it. But so that's that. Okay, so that brings us to the end of this one. So this was definitely like a trickier one, and I guess just one other thing that I want to note with this is, so a lot of people miss this one. I was kind of looking just to see like how much you could show with bearing. So I think I was, you know, lenient as long as you had like kind of a picture representing some of these parts. But anyways, I'm going to leave it at that. I will talk to you guys in another video. Thanks for watching.